Hello again, everybody. So I have this chemical reactions practice paper. If you'd like, if you have a printer, you can print this out, or you can just copy down the table on page 94 of your notebook. You can just make a table version of this right on here, and then you can still do the practice. So our example here, first one, an apple is cut into 3 pieces. What we need to think about is, am I changing my reactants into something else? So am I chemically changing this apple at all? The answer is no. So that means this is not a chemical reaction, and that is because you still have an apple. It is just in smaller pieces. So the only thing I've changed about this apple is that I've made it slightly smaller. That does not mean that I am chemically changing it. Next one, water is boiled and steam is produced. For this one, so let's think about this. Water's formula is H2O. Steam's formula is also H2O. So have I changed either of these formulas at all? No. Therefore, it is not a chemical reaction. And the reason is because it's only a phase change. We start off with water and we end up with water. Next one, baking soda reacts with vinegar. I'm sure you guys have done this one before, either at home or in class. But when you react baking soda and vinegar together, it starts fizzing and produces a lot of bubbles. We said in our notes that producing a gas or a solid is a clue that a reaction has happened. So therefore, this one is a reaction because bubbles are produced. Next one, iron rusts. So what's happening with this, we have iron plus oxygen forming iron oxide. So rust is actually iron oxide. What we've done here is we've chemically combined iron and oxygen into a new compound. And that new compound appears as a reddish-brown solid. So we produced a new reddish-brown solid. Next one, isopropanol evaporates. So what I'd like you to do right now is, before I tell you the answer, just take a second, pause the video, and make your best guess. Then once you've made your guess, restart the video and go over it. So if you've made your guess, the answer here, isopropanol evaporating, is not a chemical reaction because it is talking about a phase change. In order for something to evaporate, it has to go from a liquid to a gas. Next one, ice melting. Make your guess, then come back. Answer is no, once again, because it is a phase change. In this case, ice is a solid, and it's melting into liquid water. Next one, this one's kind of tricky. Sugar dissolves in water. Make your best guess. And the answer is no. The reason why is because you can still, if you were to boil out all of the water, you could get sugar back. So the sugar is not reacting with the water in this case. All you're doing here is you're just making an aqueous solution, which is not an example of a reaction. Next one, wood rots. So if you've ever seen rotten wood, it's kind of mushy, it's a different color, it's really, really soft, and it doesn't look or feel, or sometimes even smell like normal wood. So make your guess. The answer here is that it is a chemical reaction. That's because rotten wood is chemically different from unrotten wood. One way we can tell, we said in our notes that chemical reactions are not easily reversible. So I don't know if you've ever tried, but it's really difficult to unrot wood. That means that once wood is rotten, you can't get it back. So this is an example of a chemical reaction because it is not easily reversible. Next one, an egg cooks. So let's imagine you have a frying pan that's all hot, you crack an egg on it, and you see that the whites go from kind of clear to white, and it looks like everything's solidifying. So make your guess. The answer here is also yes. If you were to get a very fancy microscope and look at the atoms of an egg when it's cooking, you'll see that they are breaking bonds and forming new bonds. So reason here, in a way, we're producing a solid. It starts off kind of liquidy. And it's also not easily reversible. I don't know if you've ever tried, but it is just about impossible to uncook an egg once it's been cooked. All right, make a guess for paper towel absorbs water. Answer here is no, because you can squeeze all the water out of a paper towel. So you're not chemically changing anything. You're just making the paper towel wet. What I wrote there is that you can remove the water from the paper towel and neither of them are chemically changed. Next one, make your guess for salt and pepper are mixed. This one is no, because you can separate salt and pepper. In other words, it is easily reversible. And we said that in order for a chemical reaction to happen, it has to be not reversible, easily reversible. Next one, a marshmallow is toasted over a campfire. So when you toast a marshmallow, it turns either golden brown or black, depending on how long it's in the fire. And the smell changes to a sweeter smell. So make your guess. The answer is yes. You are chemically changing the marshmallow when you do this. We have a change in odor and a new solid produced. Next one, make your guess for a cube of sugar is crushed. Answer here is no. All you're doing is changing the size of the cube. You're not chemically changing it at all. In other words, it's still sugar. It just might look a little bit different. Next one, a glow stick is cracked and light is produced. Make your guess. Answer here is yes. One of the signs that we didn't talk about here, because it doesn't happen a lot, but producing light is a sign of a chemical reaction. It's like you're making a new product. When you crack a glow stick, what you're really doing is you're breaking a small glass capsule inside the glow stick, and it's releasing one reactant into another reactant to produce a product that glows when it's been mixed. And the last one, silver tarnishes. You might not have heard of this before, but back in the old days when people used real silver for silverware, if you let the silverware sit out just in the open air for a while, it would form this dark kind of a, it would not look shiny anymore, basically. It would start off very shiny and then not look shiny anymore. So think about that. Do you think that's a chemical reaction? The answer is yes. Tarnishing is the same thing for silver as rusting is for iron. So tarnished silver is a new solid. So the only way to get rid of the tarnish on silver or rust on iron is to remove the new compound that was produced, either by scraping it off or by dissolving it into something. So I hope that helps explain some of these things. You can expect another practice assignment or a mini quiz probably later this week, but I'll need to talk to the other chemistry teachers first about that. So if you have any questions, please feel free to email me, and I hope you have a great day.